No, Nabil, c'est ça? He will be speaking about how to create your own Gradle plugin.
Cool. So welcome everyone to this talk about the Gradle plugin. My name is Nabil. I work as an Android engineer at the App Business. It's a mobile software company in London. I also spent time developing open source NoSQL database called SnappyDB. And you can catch me on Twitter or GitHub. So what is a Gradle plugin? This presentation is not like initiation for Gradle. So the goal here is to present you some key concepts about creating a simple Gradle plugin, like going through the lifecycle, the build lifecycle, enhance a task, custom task, how to create your own domain-specific language, added extension to your plugin. We'll go through some live coding with some simple example. So just to illustrate the concept. So what is a Gradle plugin? Again, it is just a piece of reusable fragment logic. The idea behind it is you can encapsulate some logic and redistribute it with other projects. It defines the tasks, which are the build unit, work for Gradle, and the DSL that allows you to configure these tasks. So you can configure a task and to reuse them for different purposes. What are the benefits? First, keeping the build simple and concise. We try to avoid those large Ant and Maven build script, very verbose one. And a more important principle of software development is to have separation of concerns. So you want to, when you have a big system, you want to decompose it into small modules. To give us the ability to reuse the plugin with other projects. If they are binary plugin, you can publish them to a Maven repository and share it with other projects. So this will avoid like copy-passing a chunk of script between projects. Defines two notions, like I said, task and configuration. So if you are a service provider, like Crashlytics, for instance, your users are more interested into how to configure the knobs to use your product rather than go into the detail of implementation. So the use case study, we want to build a simple plugin that has the ability to generate a property file that will display three information. The last git commit hash, the author of the commit, and the flavor against which we compile the project. Here we have two flavors, free and paid. So I'm going ahead and show you this simple project here. I don't know if you can see from the back. So we have a pretty simple application here with two flavors. So this is the build script. We have a free flavor and a paid flavor. Each one contains about property file that, like I said, have three information, commit, author, and the flavor. We have one activity that extract this information from the assets and try to display it into three text view. I'm going to run this so give you an idea how it looks. So what we want to do is, rather than pushing this information manually each time, we want to build a plugin that does this for us each time we build the application. OK, and Genymotion just crashed. Not a good start, but OK. I'll start again and go ahead. So first, we're going to warm up a little bit and start with, here you go. We'll start with building some tasks. So I'm going to switch to presentation mode here. And I need the help of my lovely assistant to hold the mic. Okay, so here what we're going to do is build a simple task that will display the revision. We're just going to use some git commands here, say commits. I'm using Groovy, by the way, but get the commits and get the author of the commits. And then we're going to define these two methods here. So get commits. We're going to run git ref parse head execute text. Same for the author. I'm going to use a git command. And we get the author name. So I'm going to execute this task to see how it looks. So Gradle tasks will give you the list of your tasks that you can run inside your build. And you can see, I hope, I'm in the wrong project. So here we can see our task. We can go ahead and run it. Display revision. And should display the commit and the author. Let's say author. So remember, one of the requirement of our plugin is to run automatically. We don't want to do this manually here. So what I'm going to do is try to cooperate with the Android plugin to find the perfect time to add my task to the lifecycle so it can run automatically, whether the user try to build his APK from Android Studio or from command line. So to do this, we need to, this is the lifecycle of a build, an Android build. And what we try to do is make, for instance, this task, merge assets, depends on the task that we just created. So we get a free ride, like the task will run automatically. I'm going to implement this. First, let's see the list of tasks involved when you run. We try to build your free flavor with the debug build type, and I'm going to use profile here to get the list of all tasks, so you can have an idea. So this will generate a file under reports, and we are 22. Okay. So as you can see here, you have the complete list of the task to build the free debug flavor. So what we want to do is use this task. I'm going to find it. Merge asset here and make it depend on our task. So the best way to do this in Android is by using task dependency. So here I'm going to iterate through all the product flavor. And for each of one, I'm going to generate a dynamic task that will run automatically rather than a manual task. So flavor, let's use closure here. So good code review, thanks. I'm going to define the name dynamically, task, display, revision, dynamic. That's the worst name, I guess, ever. I'm going to call it display revision for the flavor name. Because like we've seen here that Android generate this task dynamically because we want to build the free flavor of the app. So if you want to build the paid, going to generate another task at runtime. So here we have the name. Let's go ahead and add the task. And we're just basically going to copy paste what we have coded here inside this task. And I don't need this one anymore. Okay. So what we did here so far is create a dynamic task and add it to the graph, directed acyclic graph for Gradle that lists all the tasks available that you can run from the command line. But what we wanted to do is try to find a particular task, the asset merge task, and make it depends on this one. So I'm going to query the Gradle model to give me all the tasks, projects, tasks, and find. I'm going to use a closure to find a specific task, and the idea is to make it depends on our task here. I'm going to use the regex to define, to try to look for my task because it gets generated with different flavor. So this is a groovy regex. Something that starts with merge, with the flavor name. We don't care about the build type, so anything will fit, and finish with assets. And we want to make this case insensitive because Android uses the camel case notation, so it's going to be F with a capital F paid with capital P. So for the demo's sake, we're going to just make this case insensitive. And we try to find matcher. Remember, this is the task name. So we can do something like task name matches, and that's it. So here we're trying to find every task that has a name, merge, something, flavor, debug, or release, and make it depends on this one. But before we run this block, we have to give an Android plugin the chance to generate this intermediate task. And usually, Android do this at configuration time. In Gradle, you have three phases. You have initialization, configuration, and execution. And depending on the flavor or the target you're trying to build, Android will build an intermediate task for it. So we want to run this after project evaluates. Come on. Projects. After evaluate, I guess. Evaluate. This is the benefit of writing a text plugin is you can have auto-completion, but when it works. Yes. And let's go ahead and run this. So I'm gonna leave the full screen. This is really stressing. I'm gonna check the yes, the project is under the name of project evaluate is under the project scope. So. I'm missing close in here. Okay. that was a lot of stress. So now if we go and build our, we're going to build the free flavor of our app. Say assemble free debug. You're going to see that our task here was executed before the merge asset task, because we made this depends on our task. And the same here if I execute the paid version. So since we generate the task dynamically, it's going to add this dependency to this task. So it was executed before this one. So here what we see is that the logic inside our task is starting to grow. And this is usually a good sign to split it into a custom task. Yes, still here. So I'm going to add an extra property before we take a look at the custom task. So since the build script is just a groovy code that drives the Gradle API, we can introduce a new variable and added them with the ext namespace. So the typical use case if we are using creating a plugin is we want to introduce a Boolean that will enable this plugin for a particular flavor or disable it for another one. And to do it, we want to write something like this, like enable about plugin true. So this will run our task or our plugin only for this flavor. And you can do this by checking when you get the flavor here if this particular flavor has a property. So we can. I have a trouble with flavor between the flavor with you, without you. Okay, has property. So this will check if the variable is defined, and if it's true, flavor. This is how you access the value defined here. So we go ahead and run this block that will generate a dynamic task. I'm going to refactor this code a little bit, so instead of just printing to the console, we're going to generate the file. So we're gonna use a property called project dir, which gives you the absolute path of your current project. So if you're not sure about the variable name, you can ask Gradle to give you all the properties you can use. So this will display all like environment variable you can use, and this is the one I'm using here. So it gives you the full path of your project, so you can. It's handy if you want to generate file, for instance. So the path is project dir src flavor name, and it's inside assets, and the name is about properties. Okay, and I'm going to grab a writer, and you can see this. Can you still read with this or no? Okay. Sorry. Okay. So here is just going to just warn the user it's auto-generated file. Auto-generated, do not edit. And I'm just basically going to copy paste this and write it inside there. Now remember, our plugin displayed three information: the commit, the author, and the flavor. So now we got the information about the flavor, so we can add it to our property file. Flavor name. All right, so let's run this project. I'm going to exit here, so full screen. It's not what I wanted to do. Okay, so here I'm going to delete this property file so we can make sure that our task really generated the file. So I'm gonna run the free debug assemble and another. Come on, code reviewers. Okay. Cool. So our task run, as you can see, display revision for free. And we're expecting to see a property file that get generated here. So here's our property file. So if I run it for the paid, which is not a flavor that we want to generate the property for, the task will not run because we disabled this with the extension namespace. So what is cool also is you come here, is that Android Studio use the same Gradle command to build your project. So if I delete this file and we'll just compile the project, Android Studio will run my task because it's part of the lifecycle. And Android Studio use a tooling API, which is an API provided by Gradle to drive your build. So if I show you the console output here, you can see that if I clear here and I do the build, you can see that Android Studio is running, invoking assemble free debug. So this is something that Google tried to push now, is having that the IDE is just the front end to show stuff and let the build tool handle everything. This isn't something we had with Eclipse when you had like an internal build tool, and if you want to go to CI, you have to run a different Ant script. So this is something cool. All right, we're back to our slides. Where are your slides? Yeah, I mentioned the custom task. They are just simple tasks. It allows you to encapsulate the logic inside the task, inside the class that you can test and reuse. So it's highly configurable and testable. And it extends a default task by Gradle. Gradle gives you a lot of default class, like the one to copy the file or directory. We're going to use the default one to create this one. So the big advantage here is that you can test it and reuse it. So instead of having all the logic here, going back to presentation mode, instead of having the logic about creating the file and generate, which is kind of ugly because it adds a lot of noise to your build script, we're going to encapsulate it into a class, a custom task. Nope. We're going to call it about task that extends the default task from Gradle, and it's just a simple task. We can define a method here that will execute our action mode, and we're going to use annotate with task action. So we tell Gradle that this is the block we want to execute. All right. So we're going to merge this spoiler code here and inside the task. And we don't need this task creation anymore. And I'm going to add it, since the only thing that changed here is the flavor. I have two, free and paid. So I'm going to introduce a variable here called flavor, US style. And you're going to understand why. And I'm going to use it here. The rest is the same. So you can also move this block here inside this class. So now our build script looks more cleaner. And to be able to run your custom task, you need to create what we call an enhanced task. Enhanced task is a task that mention or tell Gradle which type of class it have to instantiate to run this task. So the new way now to create our enhanced task is by using this API. We're going to use a name. Name is the same. Where are you? All right. We're going to tell Gradle which type of task is this. So it's about task. So this piece of code here will tell Gradle, okay, instantiate this class and run this method here. Pretty simple. And since we have a flavor parameter here, we can configure it with a closure. So you can write something like flavor, cat flavor name. Just to avoid naming collision here, I name it flavor. So now we have a task that we can reuse for free and paid, and it's encapsulated inside a clean class. So this still run, I hope. So it didn't run for the paid because it's the paid. And something wrong. So what happens at line 67? Okay. Yeah, I forget this. Project dir. Project dir is defined inside the project scope. So since we moved all this logic inside this custom task, we have to mention it with the full namespace if you want. So projects.project dir. And I think that's it. Yeah, we get our task here. Okay, we've seen the custom task, how they're cool. Now we're going to see the DSL. I'll have to go really fast. And DSL gives you the ability to talk about things. Like I said, it gives the user the vocabulary to define things. And what we want to do here is added a custom DSL that will customize the name of the file we generate. So instead of being about that properties, we can have another name here. So the way to do this is to, this is what we want to write is something like this, right? File name, this is our custom DSL. I'm going to call it info. So every DSL needs to be backed by an object that will capture the value from the DSL and inject it to your project. So you need to define like a plain old Java or Groovy class. We're going to call it about extension. It's just a pogo that will capture this value. So here it's just a string, and we can give it a default name, which is about. So if the user doesn't specify any DSL, it's still run. So to register DSL, we need to introduce at this point our plugin class. So plugin class is just a class that implements a plugin interface from Gradle. Plugin. Okay. Shut up. And I don't know what the WebKit plugin. Okay, I've read the documentation. Okay. I don't want to do this. Yeah. Apply. That takes a project instance. Okay. And he's happy. So now we have, remember, we have our extension here. We have the class that will capture the value, and we can use the extension API to register this. So project extension create, and this is the namespace of our extension. It's called about. It have to match the one obviously we want to add, and this is the class that will capture the value. Everything you see here is a DSL. So this is a DSL that's specified the SDK version name. This is a DSL, same here. So all of these are backed by class that get this value from. So okay, here we have our extension registered. So now we can use it inside our class. So instead of having this hard-coded value here, we can use something like, it's gonna explode. I'll go fast. Project dot about, this is a new namespace we add, and file name. It doesn't like the comma. We can do this because the about here is an instance of this class. So you can access to this property here on read or write. You can set it or just read the value. So this is cool. So since we have our plugin class, let's go ahead and move all this logic outside of the Android build script, but to move it inside the plugin class. Okay, and remember this is a DSL from Android, so we need to specify the fully path to its project.android, because Android defines what is a product flavor. And I think it's pretty much it. So now we have our extension, we have our class, we have our plugin that will wire things up. It wires the DSL with the task. So we can go ahead and apply it. So the way to apply the plugin is by calling the name of the class or give it a name that you're gonna look for it on the class path. Okay. And when I do this is I'm adding new behavior to my build script. I'm adding two things, a new task like display revision that will generate the file, and adding new DSL. So now our Android script is limited to this part only, and it's more clean and more concise. So let's run this. It never works the first time, but told you. Okay, no such file. Okay. Okay. This is a bad idea. Yeah, the about here. About properties. Cool. So we get our task executed by Gradle, and yes, but can you see here, there's a small problem here. Can you spot what is wrong? I think you gave a hint to your presentation to this, something that Bug did well comparing to Gradle so far. Anyone? Can you spot a problem here? Yes, one of the problems. Here I'm running my task every time, and this is completely a waste of build time because I didn't change anything. I didn't change the commit. I didn't commit anything. I didn't change the author, and I didn't delete the file. So we're going to fix this by using incremental build. So what it is Gradle's ability to skip chunk of work if it can detect that the inputs didn't change and the output is still there. But you need to tell Gradle what are the inputs and the outputs. So we can use this simply by the task level by saying, hey Gradle, by the way, this is an input. This is something that could change. And as an input, we have also the commits, the author. And the only thing we provide is this file here. This is our only output. So we can define get output file. here. Def, don't care. Output file. This is pretty easy with Gradle. And here I have to call this. So now we're telling Gradle exactly what are the input and the output of our plugin or our task. So now if I delete the file, for instance, I delete both here. Yes, I want to delete, thanks. And the first time I changed the output, so the task should run, obviously, here. But if I run it again, it says up to date. This means that Gradle just skipped this. A really cool thing to optimize your build time. So no more slides. But still, I have the final form of the project I wanted to show you, because so far, like I said, this is my time boxing for the presentation, by the way. We've been building a text plugin. So what you can do is build a binary plugin that you can package as a jar and push it to a Maven repo so other projects can use it. And so what I did here is just split the logic that I had inside this build script inside 3 different files. And you can see it's completely the same code, but inside, groovy files. And this is a completely other project, not related to the Android project. It's a project that it's built with Gradle. And I'm going to switch here to a presentation. This is too much. This will just produce a jar with this information, and it applies the Maven plugin so we can publish to a Maven repository. So here, just for the sake of the demo, publish into a local repository. So I can build this with Gradle also. So if I do clean, upload, archives. Okay, I'm offline, so sorry. Offline. Don't try to get anything from the internet. That's it. We get our plugin here. Publish it at this location. And we can use it in our Android project. I'm going to finish with this. We can use it, instead of applying the class, we're going to specify the name of the plugin. So the plugin has a metainf file inside it. So this is the name of the plugin that you want to publish. So if you're using Android plugin, it have to have android.properties. And this file contains the entry point of your plugin. It's just a descriptor that says to Gradle, OK, go to this implementation in order to instantiate the plugin. So now in my Android project, I can reference this here. So instead of applying the class, you can apply the actual name of the plugin. And Gradle will look into the class path to look for a specific jar with this descriptor. And the final advantage of using another one, it's not the final, of using binary plugin is testing. I'm going to go really, really fast on this. I wrote some tests just to show you how you can test your build script. This is something new we didn't do previously with Ant or Maven. Now, not only we're testing our application, we're testing our build script. And this is really cool. We use, like I mentioned, the tooling API, which is an API to drive your Gradle plugin. And here you have 4 important steps. This is a test that will run automatically the assemble-free debug task and try to see if the outputs correspond to what we expect, like the generated file. So the 4 steps are simple. You grab a Gradle connector, and you connect to a specific directory that contains a Gradle project. once you have a connection, you can create a launcher, and then you can run tasks like you run them in the command line. So here, I'm programmatically starting a project and starting task, and you can do after classic assertion that the file exists. That's it for me. Thanks for listening.
Who wants to, you have any questions?
I will publish this plugin later on my GitHub, so you can get the slides and the complete source code for it. Anything Gradle related? Yeah.
Hi.
Hey.
So we've heard a small talk before you, just before you, from the Facebook guy about Buck, and from you about Gradle, and it's all good. But I'm interested about how you plan on doing integration with projects that contain native code. So I'm talking about a deeper integration than just packaging a jar.
This is a great question.
And a painful one, I hope.
Yeah, because I was working on SnappyDB, and I import some native code, a C++ code, and I was trying to find a way to push this so the Maven user can use it, the Gradle user can use it. And one of the problematic is the Maven guys didn't support fully the new Android archive format correctly as specified by Google. So they ignore completely your native library first. And if you embed some library inside libs, they ignore them. So the only thing they take is the code and resource. So I filed an issue. I think it's fixed on Master 4.0, but it's not yet released. So to answer your question is, I think the best way now to release native code is through AR, because it supports native library. So you can import every ABI, ARM, x86, and you can define product flavor per ABI. So if you have a project that uses a library that has native code, you import everything. But at project level, you specify the want you want to export. So you ignore MIPS or ARM or whatever. Was this the question or no?
One thing is supporting just a native library, so a binary. Yep. But another thing is supporting code which is being built with Gradle from C++ to an SO file.
Yeah, they started the small work with the NDK, but for now you have two ways now. You can either issue a command, like NDK build, and you specify your alt toolchain, whatever. This is what I use personally. Or the other way is they're starting to build a DSL to do NDK build, but it's still really very early stage, and you can specify a lot of flags, I guess. So a lot of users are just defining the task that execute a command that will build. So this is really an area that we're expecting, the Android guys to enhance their plugin. I'll be there for 2 days, so not here. Thanks.